There's a fundamental assumption most people make when thinking about the speed of light. The idea that light travels at a specific speed limit of 300,000 kilometers per second because of some physical constraint on how fast photons can move through space. That light is like a very fast car hitting its maximum speed due to engine limitations or air resistance. That if we could somehow give photons more energy or remove obstacles, they might go faster. That the speed of light represents a barrier that could theoretically be overcome with advanced technology like warp drives or hyperspace. This intuitive picture treats the speed of light as just another speed that happens to be very fast, something that limits travel time and communication, but that doesn't fundamentally reshape our understanding of space, time, and causality. The narrative in popular science often reinforces this misconception by describing light's speed as the ultimate speed limit without explaining why such a limit exists. By focusing on the practical implications for space travel and communication without addressing the deeper physics, by using the term speed of light, which suggests that light is moving through space at some rate, and by comparing light speed to other speeds like sound or spacecraft velocities, making it seem like a quantitative difference rather than a qualitative transformation of physics. Science fiction contributes to the confusion with faster-than-light drives that violate relativity as if it were merely an engineering challenge rather than a logical impossibility. With time travel paradoxes treated as plot devices rather than fundamental contradictions, creating the impression that light speed is a barrier we might eventually overcome. And I'm going to tell you why everything about this picture is wrong, and why the speed of light is not really a speed at all, but rather represents the structure of spacetime itself. Why light doesn't actually travel in the conventional sense, but rather traces the geometry of the universe. Why the limit is not a restriction on motion, but a conversion factor between space and time that's built into the fabric of reality. Why nothing with mass can reach light speed. Not because of energy requirements, but because the concept of reaching light speed is meaningless for massive objects. Why faster-than-light travel doesn't just violate physics, but violates logic itself, creating contradictions equivalent to drawing square circles. Light doesn't travel in the sense we intuitively understand travel. Instead, light defines what it means for events to be connected. Light traces the boundary between past and future. Light reveals that space and time are not separate, but are unified in space-time, where what we perceive as motion through space is really rotation in space-time. What I mean by light doesn't travel requires careful unpacking, because obviously, light gets from the sun to Earth, taking about 8 minutes. From distant galaxies to our telescopes, taking billions of years. We measure light's speed and use it for countless technologies, from fiber optics to GPS. Saying light doesn't travel seems to contradict direct experience. I'm making a precise claim about the nature of motion through space-time. From light's own perspective, if such a thing made sense, no time passes during its journey. Light experiences no duration between emission and absorption. The 8 minutes from sun to Earth is only experienced by us, the observers, not by the light itself. Furthermore, light doesn't accelerate from rest to light speed. It is created already moving at light speed and cannot move at any other speed. Light follows null geodesics in space-time, which are fundamentally different from the time-like paths that massive objects follow. Understanding what this means requires rethinking motion itself. The distinction between speeds below light speed and light speed itself is not quantitative, but qualitative. It's not that light is very fast compared to slower things. It's that light occupies a completely different category of existence in space-time. Massive objects move through time, experiencing duration, and can move through space at various speeds up to but never reaching light speed. Massless particles like photons don't move through time at all in their own frame and always move at exactly light speed in every frame, regardless of the motion of the source or observer. This absolute constancy of light speed in all reference frames is not a property of light, but a property of space-time geometry. The speed we call c is really the conversion factor between space and time coordinates in the metric structure of spacetime. Let me start by examining what special relativity actually says about light speed and why Einstein's insights fundamentally changed our understanding of space and time. The constancy of light speed was the starting point for Einstein's 1905 special relativity theory. He postulated that the speed of light in a vacuum is the same in all inertial reference frames, regardless of the motion of the light source or observer. This seems impossible from everyday intuition because speeds are supposed to add. If you're on a train moving at 100 kilometers per hour and throw a ball forward at 50 kilometers per hour, the ball moves at 150 kilometers per hour relative to the ground. But if you shine a flashlight forward, the light doesn't move at light speed plus the train speed. It moves at exactly light speed as measured by both you and ground observers. The Michelson-Morley experiment in 1887 had already demonstrated this puzzling result by showing that light speed is the same in all directions regardless of Earth's motion through space. Physicists expected to find differences in light speed, depending on direction, because Earth moves around the Sun, which moves through the galaxy, which moves through the universe. If light traveled through a medium called the luminiferous ether, then Earth's motion should create an ether wind, making light slower in some directions and faster in others. But the experiment found no difference. Light speed was constant in all directions to extraordinary precision. This null result was deeply puzzling until Einstein explained it. Einstein's explanation required abandoning absolute time and absolute simultaneity. If light speed is constant in all frames, then observers moving relative to each other must disagree about measurements of time and space. Time dilation means moving clocks run slow. Length contraction means moving objects are shortened. Simultaneity is relative. Events that are simultaneous in one frame happen at different times in another frame. These effects are not optical illusions or measurement artifacts. They represent genuine differences in the structure of spacetime as experienced by different observers. Space and time are not absolute backgrounds, but are observer-dependent projections of a unified four-dimensional spacetime. The spacetime interval is the fundamental invariant quantity that all observers agree on, even though they disagree about space and time separately. The interval between two events is given by the formula. Interval superscript 2 equals C asterisk time superscript 2. Space superscript 2. In appropriate units where we set C equals 1, it's just time superscript 2, space superscript 2. This minus sign is crucial because it makes the geometry of spacetime fundamentally different from the geometry of ordinary space. In ordinary space, the distance between 2 points is always positive and is calculated by Pythagoras' theorem, adding square coordinate differences. In spacetime, the interval can be positive, negative, or zero, creating three distinct types of separation between events. These three types of spacetime intervals correspond to time-like, space-like, and null separations. Asterisk time-like intervals have a positive squared interval, meaning the time separation exceeds the space separation. A massive particle could travel from one event to the other, experiencing time passing between them. Asterisk space-like intervals have a negative squared interval, meaning the space separation exceeds the time separation. No particle or signal can travel from one event to the other, because doing so would require exceeding light speed. Asterisk null intervals have a zero squared interval, meaning time and space separations exactly balance. Only light or other massless particles can connect these events. These null intervals define the light cone structure of spacetime. The light cone from any event divides spacetime into past, future, and elsewhere. The future light cone contains all events that can be causally influenced from the original event, events that can be reached by signals traveling at or below light speed. The past light cone contains all events that could have causally influenced the original event. The region outside both cones, called elsewhere, contains events that are space-like separated, meaning no causal connection is possible. Different observers disagree about the time ordering of space-like separated events, showing that simultaneity is relative. But all observers agree about the light cone structure and the distinction between time-like, space-like, and null intervals. Light travels on the boundary of the light cone, along null world lines connecting events with zero spacetime interval. This is fundamentally different from massive particles, which travel inside the light cone, along time-like world lines, experiencing a non-zero interval. The world line of a massive particle is its trajectory through spacetime and always stays within its past and future light cones. Accelerating or changing direction changes which time-like path you follow, but cannot make you reach the light cone boundary itself. Light, in contrast, is always on the light cone boundary and cannot deviate from it. This is why light speed is absolute and why massive object cannot reach it. The geometry of spacetime makes light speed special not because photons are special particles, but because null geodesics are special curves in spacetime geometry. Geodesics are the straightest possible paths through curved spacetime, generalizing the notion of straight lines in flat space. Time-like geodesics are followed by objects in free fall, experiencing no forces. Space-like geodesics don't correspond to physical particle paths because you cannot travel faster than light. Null geodesics are followed by light and represent the structure of causal connection in spacetime. The speed of light is the geometric property that separates time-like from space-like from null. So, examining special relativity reveals. Light speed's constancy led Einstein to spacetime unification. Time dilation and length contraction follow from constant light speed. The spacetime interval, not space and time separately, is the fundamental invariant. Spacetime has three types of intervals, creating a light cone structure. Light travels on the light cone boundary, null intervals. Massive particles travel inside, time-like intervals. Light speed is a geometric property of spacetime, not a property of light itself. The world lines of light and matter are fundamentally different categories in spacetime geometry. Understanding this requires abandoning the idea that light is just very fast and recognizing that light occupies a unique position in the structure of spacetime, defining causality itself. Now, let me examine what happens to space and time as objects approach light speed, which reveals why reaching light speed is impossible for massive objects. Time dilation increases as velocity increases, approaching infinity as velocity approaches light speed. The time dilation factor is gamma equals 1/square root 1 v superscript 2 / c superscript 2. For small velocities, gamma is close to 1, meaning minimal time dilation. At 90% of light speed, gamma is about 2.3, meaning moving clocks run 2.3 times slower than stationary clocks. At 99%, gamma is about 7. At 99.9%, gamma is about 22. As velocity approaches light speed, gamma approaches infinity. This means infinite time dilation. What does infinite time dilation mean? For an object traveling at light speed, which it can't, no time would pass in its own reference frame. If you could travel at light speed, your journey from Earth to a distant galaxy would be instantaneous from your perspective, even though billions of years pass on Earth. This seems paradoxical because travel taking no time seems to involve infinite speed, not finite light speed. The resolution is that length contraction also becomes infinite at light speed, making the distance traveled shrink to zero in your frame. From your perspective, both time and distance are zero, making speed undefined. This is why we say that light experiences no time and no distance during its journey. Length contraction also increases without bound as velocity approaches light speed. The length contraction factor is 1/gamma, meaning objects are contracted by the same factor that time is dilated. At 90% of light speed, objects are contracted to about 43% of their rest length. At 99%, they're contracted to about 14%. Approaching light speed, the length contraction approaches 100%, meaning objects shrink to zero thickness in the direction of motion. This doesn't mean objects are crushed, but rather that the spatial dimension parallel to motion becomes compressed. The geometry of space itself changes. The mass increase sometimes described in older textbooks is really an increase in relativistic energy, not an increase in rest mass. The concept of relativistic mass equals gamma asterisk rest mass, is now considered outdated because it obscures what's really happening. The rest mass of an object never changes. What increases is the object's energy and momentum at very high velocities. An object's total energy is E equals gamma asterisk m asterisk c superscript 2. As velocity approaches light speed, this energy approaches infinity. Even though rest mass remains constant, this infinite energy requirement is why you cannot accelerate a massive object to light speed. The energy required to accelerate an object increases without bound as velocity approaches light speed. Accelerating from 0 to 50% of light speed requires a certain energy. Accelerating from 50% to 90% requires much more energy. Accelerating from 99% to 99.9% requires vastly more. There is no upper limit to how much energy you'd need because the energy requirement goes to infinity as you approach light speed. You could spend the entire energy output of the universe and still not reach light speed. This is not an engineering limitation. It's a fundamental impossibility built into spacetime geometry. The closer you get to light speed, the more energy is needed for each additional increment of speed. The velocity addition formula shows why speeds don't simply add in relativity. If you're moving at velocity u relative to Earth and shoot a projectile forward at velocity v relative to you, the projectile's velocity relative to Earth is not u plus v. It's u plus v / 1 plus uv / c superscript 2. This formula ensures that if either velocity equals c, the result equals c. If you're moving at 90% of light speed and shoot a laser forward, the laser moves at exactly light speed, not 190% of light speed. You cannot reach light speed by adding velocities because the velocity addition formula has light speed as an asymptotic limit. The limit as rest mass goes to 0 is crucial. For massive particles, E equals gamma asterisk m asterisk c superscript 2. As v approaches c, gamma approaches infinity. So energy approaches infinity for any non-zero m. But photons have 0 rest mass. This formula gives 0 asterisk infinity, which is undefined. The resolution is that photons must move at exactly light speed, never faster or slower, and have energy given by E equals h asterisk f, Planck's constant times frequency. Photons don't gradually accelerate from rest to light speed. They're created already moving at c and cannot exist at any other speed. So, examining what happens as we approach light speed shows. Asterisk time dilation approaches infinity, making time stop for objects at light speed. Asterisk length contraction approaches infinity, making distances shrink to 0. Asterisk relativistic energy approaches infinity, making acceleration to light speed impossible. Asterisk the velocity addition formula has light speed as an asymptotic limit, preventing reaching c by adding velocities. Asterisk massless particles must move at exactly c, never slower or faster. These mathematical behaviors reveal that light speed is a boundary in spacetime, separating massive particles, which move slower than light, from massless particles, which move at light speed. The boundary cannot be crossed because the mathematics becomes singular and the physics becomes meaningless. Now, let me examine the causal structure of spacetime and why faster-than-light travel would violate causality, creating logical contradictions. The light cone structure determines which events can influence which other events through cause and effect. An event at a particular spacetime point has a past light cone, containing all events that could have caused it, and a future light cone, containing all events it could cause. Signals and influences propagate at or below light speed, tracing world lines inside or on the light cone. This structure ensures that causes precede effects in all reference frames, maintaining logical consistency. Faster-than-light signals would connect events that are space-like separated, lying outside each other's light cones. The problem with space-like separated events is that different observers disagree about their time ordering. In some reference frames, event A happens before event B. In other frames, B happens before A. If space-like separated events could be causally connected through FTL signals, then the notion of cause and effect breaks down because different observers would disagree about which event caused which. You could have situations where observers disagree about whether a signal was sent before or after it was received. The tachyonic anti-telephone thought experiment illustrates the paradox. Imagine Alice and Bob moving away from each other at relativistic velocity. Alice sends a faster-than-light message to Bob, who immediately sends a faster-than-light reply back to Alice. Due to the relativity of simultaneity, the reply can arrive at Alice before she sent the original message in Alice's reference frame. This creates a backwards-in-time signal, allowing Alice to receive information from her own future. She could use this to prevent herself from sending the message, creating a grandfather paradox, where the effect prevents its own cause. The grandfather paradox, in its classic time travel form, asks what happens if you go back in time and kill your grandfather before your parent was conceived. If you succeed, you're never born, so you can't go back in time, a contradiction. If you fail, then there's no paradox. But the question is why you necessarily fail. FTL travel creates the same paradox because moving faster than light in space is equivalent to moving backwards in time for appropriately moving observers. The spacetime geometry of relativity makes FTL and time travel to the past fundamentally the same thing. Both violate causality in the same way. The resolution that causality violation is impossible means that faster-than-light travel must be impossible. It's not that FTL is merely difficult or requires exotic technology. It's that FTL creates logical contradictions equivalent to making a statement both true and false simultaneously. Physics cannot permit self-contradictory situations. Therefore, FTL cannot occur. This is a stronger prohibition than mere physical impossibility. It's logical impossibility, comparable to drawing square circles or making bachelors married. The geometry of relativistic spacetime makes FTL logically incoherent. An alternative resolution that closed time-like curves could exist allowing time travel without contradiction requires consistency conditions where the past cannot be changed. In this scenario, if you travel back in time, your actions were always part of history. So, killing your grandfather is impossible because history already shows he lived. This saves logical consistency, but at the cost of denying free will, because your future actions would be predetermined to avoid paradoxes. Most physicists find this resolution unsatisfying and believe that consistency conditions indicate closed time-like curves simply don't exist in nature. The preferred resolution is that spacetime structure forbids closed time-like curves and FTL travel through the fundamental properties of general relativity. Solutions to Einstein's equations that contain closed time-like curves, like the Gödel metric or certain black hole interiors, are considered unphysical. The chronology protection conjecture, proposed by Stephen Hawking, suggests that the laws of physics prevent closed time-like curves from forming through quantum effects that create infinite energy densities. While not proven, this conjecture represents the widespread expectation that nature avoids causality violations. The wormhole solutions in general relativity that might allow shortcuts through space, creating effective FTL travel, face severe problems that likely make them impossible. Traversable wormholes require exotic matter with negative energy density to hold the throat open against collapse. Negative energy exists in quantum field theory through effects like the Casimir effect, but only in tiny amounts over small distances. Creating a wormhole large enough for a spaceship would require amounts of negative energy exceeding anything we can imagine producing. Furthermore, traversable wormholes can be converted into time machines, creating the same causality violations as direct FTL travel. So, the same arguments that prohibit FTL probably prohibit traversable wormholes. The Alcubierre warp drive, proposed in 1994 as a solution to Einstein's equations, allows faster-than-light travel without locally exceeding light speed by contracting space in front of spacecraft and expanding it behind, creating a wave of spacetime that carries the ship. The ship itself remains stationary within its local bubble of flat spacetime, so it doesn't violate the local light speed limit. However, the warp drive requires enormous amounts of negative energy. Initial calculations suggested negative energy equivalent to the mass energy of Jupiter. Later refinements reduced this, but still requires macroscopic negative energy. Additionally, the warp drive can be used to create closed time-like curves and violate causality. So, it likely shares the same prohibitions as other FTL mechanisms. Quantum mechanics also presents a fundamental barrier. The no-communication theorem proves that quantum entanglement cannot be used for FTL communication. Even though entangled particles have correlated properties instantaneously across any distance. When you measure one particle, you cannot control the outcome. The distant observer cannot tell from their measurement alone whether you've measured your particle or not. To compare results and see the correlation, you must communicate via classical, slower-than-light channels. So, entanglement cannot transmit information faster than light, despite the instantaneous correlation. The structure of quantum field theory itself enforces causality by requiring that measurements at space-like separated events commute. Their order doesn't matter, ensuring one measurement cannot influence the other instantaneously. So, examining causal structure shows. Asterisk light cones determine which events can influence each other. Asterisk FTL signals would connect space-like separated events, whose time ordering is relative. Asterisk the tachyonic anti-telephone creates grandfather paradoxes through backwards in time signals. Asterisk relativity makes FTL equivalent to time travel, violating causality. Asterisk logical consistency requires that causality violations are impossible. Asterisk wormholes and warp drives require exotic matter and can create time machines. Asterisk quantum entanglement cannot transmit information faster than light. Asterisk quantum field theory structure enforces causality through commutation relations. These multiple independent lines of reasoning show that FTL is not just difficult, but logically impossible within the framework of relativity and quantum mechanics. Now, let me examine what it means for light itself to move at light speed and why photons experience no time during their journey. Understanding light's perspective reveals the deepest truths about space-time structure. The proper time along a world line is the time experienced by an object traveling that path, calculated by integrating the space-time interval along the world line. For massive particles moving slower than light, the proper time is always positive and represents the actual duration experienced. For light traveling on null world lines, the proper time is zero because the space-time interval along a null curve is zero by definition. This means photons experience zero duration between emission and absorption, regardless of the spatial distance traveled. A frame of reference for a photon doesn't actually exist in special relativity. You cannot boost into the rest frame of something moving at light speed. The Lorentz transformation that relates different reference frames becomes singular as velocity approaches c, with infinite time dilation and length contraction. There's no coherent notion of what the universe looks like from a photon's perspective. Talking about a photon's perspective is shorthand for taking the limit as velocity approaches light speed, which gives zero time and zero distance. But strictly speaking, this limit doesn't represent a valid reference frame. Imagine traveling from Earth to the Andromeda Galaxy, 2.5 million light-years away, at increasing velocities. At 99% of light speed, the journey takes about 2.5 million years Earth time, but only about 350,000 years in your frame due to time dilation. At 99.9999%, it still takes 2.5 million years Earth time, but only about 1,100 years in your frame. As you approach light speed, your experience time approaches zero. Light itself experiences the zero limit where the journey is instantaneous. The distance contraction is equally extreme. As your velocity approaches light speed, the distance to Andromeda contracts. At 99.9999% of light speed, it contracts to about 35 light years in your frame. Approaching light speed, the distance contracts to zero. From a photon's perspective, the entire journey is compressed to a single point with no distance between source and destination. This makes sense because if no time passes, then speed would be distance divided by zero, which is undefined unless distance also goes to zero. Zero time and zero distance together make the journey both instantaneous and of zero length. The implications for causality are profound. For the photon, emission and absorption are the same event in the photon's history. There's no during the journey for the photon because its entire existence from creation to annihilation is a single moment with no duration. We observe light taking time to travel from source to detector, but light doesn't experience that time. This is not just extreme time dilation. It's the complete absence of experience duration. Photons don't age, change, or have histories because history requires time, which they don't experience. What is frame-independent is that absorption and emission happen. All observers agree about these events. What's frame-dependent is how long the journey takes and how far the photon travels. Different observers measure different times and distances for the same photon journey, but all agree about the emission and absorption events. The spacetime interval between them is zero in all frames, showing that this null separation is an invariant property of light's journey. The zero interval is what makes light special, not that it travels at a particular speed. The energy and momentum of photons are perfectly well-defined despite having zero rest mass and experiencing no time. Photon energy E equals hf and momentum P equals E/c. These quantities are frame-dependent. Different observers measure different energies due to Doppler shift. But in all frames, photons carry energy and momentum, making them physical entities. The energy-momentum 4 vector for photons is null, meaning its squared magnitude is zero, consistent with zero rest mass. Light also exhibits wave properties. As a wave, it has frequency and wavelength related by lambda f equals c. The wave-particle duality is resolved in quantum field theory, where light is an excitation of the electromagnetic field and particle-like behavior emerges in quantum measurement. But both descriptions agree that light propagates at exactly light speed, never faster or slower. So, examining light's perspective reveals asterisk photons experience zero proper time, making their journeys instantaneous from their perspective. Asterisk photon reference frames don't technically exist because Lorentz transformations are singular at light speed. Asterisk the limiting behavior as velocity approaches, C shows time and distance both going to zero. Asterisk emission and absorption are, from the photon standpoint, the same event with no duration between. Asterisk photons don't age or change during propagation because they experience no time. Asterisk energy and momentum are well-defined despite zero rest mass and proper time. These properties show that light occupies a unique category in space-time, neither moving through time like massive particles nor existing statically, but rather defining the boundary between past and future. Now, let me examine the deeper geometric meaning of light speed as a fundamental property of space-time rather than a property of light. Understanding this reveals why c appears in equations throughout physics. The metric structure of space-time determines distances and angles. In special relativity, it's the Minkowski metric with signature dash plus, 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 1 time-like and 3 space-like dimensions. The key feature is the minus sign in front of the time term, which makes time fundamentally different from space. The speed of light c appears as the conversion factor between time units and space units in the metric. The invariance of the space-time interval shows that c is really a unit conversion, not a speed limit. The interval formula is interval superscript 2 equals c asterisk time superscript 2 space superscript 2. Here, c converts time into the same units as space, so they can be combined. If we measure time in seconds and space in meters, then c equals 300 million meters per second converts seconds to meters. But we could measure time in light seconds. The distance light travels in 1 second. Then, 1 light second per second equals 1. So c equals 1, a dimensionless constant. This shows that c is fundamentally a geometric property of how space and time relate, not a velocity. The deep reason why c is finite rather than infinite is that space and time are unified into spacetime. If they were completely separate, signals could propagate instantaneously. C infinite. But unification requires a finite conversion factor. The particular value of c in meters per second is arbitrary, a consequence of our historical choice of the second and the meter. What matters is that it's finite. C appears throughout physics as a conversion factor. In E equals mc squared, the c superscript 2 converts mass units to energy units, showing mass-energy equivalence. In the relativistic energy-momentum relation, E superscript 2 equals pc superscript 2 plus mc superscript 2 superscript 2. C converts momentum to energy. In general relativity, C appears in the field equations relating spacetime curvature to energy momentum. The question of why electromagnetic waves travel at c is answered by recognizing that all massless particles must travel at c. It's not that light is special. It's that c is the speed of null geodesics. Gravitational waves also travel at c because gravitons are massless. If there were other massless particles, they'd travel at c too. The property is masslessness, not being light. So, examining the geometric meaning shows. C is the conversion factor in the spacetime metric between time and space. Its appearance in physics equations reflects its role as a spacetime unit converter. The particular numerical value is conventional depending on unit choices. All massless particles travel at c because c is the speed of null geodesics. C is fundamental to the structure of physical law, ensuring Lorentz invariance. Now, let's look at the overwhelming experimental evidence. The Michelson-Morley experiment, 1887, was the first precision test, showing light speed is the same in all directions regardless of Earth's motion. Modern versions confirm this to better than 1 part in 10 superscript 1. The constancy of c is a bedrock fact. Time dilation is directly confirmed. Cosmic ray muons, created high in the atmosphere, have a half-life of 2.2 microseconds. Even at near light speed, they shouldn't reach the ground. But because of time dilation, their lifetimes are extended, and they do reach us exactly as predicted. Particle accelerators see the same effect. Unstable particles moving at 0.99 c live much longer than their rest frame half-lives. The Haffel-Keating experiment, 1971, flew atomic clocks on airplanes. The clocks on the fast-moving planes ran slower than ground clocks by exactly the amount predicted by special relativity, combined with gravitational effects from general relativity. The Global Positioning System, GPS, is a continuous, practical test. GPS satellites move at high speeds and are in a different gravitational potential. If relativistic time dilation corrections weren't applied, the system would accumulate errors of about 10 kilometers per day. The fact that GPS works with meter-level accuracy is daily proof of relativity. Particle accelerators like the LHC couldn't function if relativity were wrong. The design of their magnets and the energy calculations for accelerating protons to 99.9999991% of light speed rely entirely on relativistic formulas. The observed particle behavior at these energies matches relativistic predictions perfectly. Light from distant cosmic sources, supernovae, gamma-ray bursts, arrives at the same speed regardless of the source's motion toward or away from us. If light speed depended on the source's velocity, we'd see variations. We don't. The recent detection of gravitational waves from a neutron star merger by LIGO provided a beautiful test. The gravitational waves and gamma-ray light arrived at Earth within seconds of each other after traveling 130 million light-years, confirming that gravity also travels at sea. The experimental evidence is vast, precise, and consistent. Relativity is one of the most rigorously tested theories in science. Finally, let's reflect on the profound philosophical and conceptual implications. The block universe interpretation follows naturally. Since simultaneity is relative, there's no universal now. The most coherent view is that all of space-time, past, present, and future, exists as a four-dimensional block. What we experience as the flow of time is our consciousness moving along our world line through this block. This raises deep questions about free will and determinism. Though quantum mechanics introduces genuine randomness that may complicate a purely deterministic block, causality becomes geometric. Cause and effect are determined by light cone structure. An event can only cause events in its future light cone. This makes causality a structural feature of space-time geometry. Causality is more fundamental than time in this picture. Our subjective experience of time flowing remains a mystery. It may be an illusion, an artifact of thermodynamics, increasing entropy creating an arrow of time, or a feature of consciousness itself. Reconciling this experience with the static block of relativity is an open question at the intersection of physics, philosophy, and cognitive science. The relationship between relativity and quantum mechanics creates tension. Quantum mechanics treats time as an external parameter for wave function evolution. Fully merging the two into a theory of quantum gravity is the great challenge of modern physics. Some approaches suggest space-time itself might be emergent from more fundamental quantum structures. If so, the speed of light might also be an emergent property. This remains speculative. What if c were different? If c were infinite, we'd have Newton's universe. Absolute time, instantaneous action at a distance, no relativity. If c were much smaller, relativistic effects would be part of daily life, but chemistry and atomic structure would be different. Life, as we know it, might not be possible. The value of c seems fine-tuned for a universe that can produce complex structures and observers. In conclusion, light doesn't travel in the sense that it experiences a journey. From its perspective, there is no duration, no distance. The speed of light is not a speed limit. It is the geometric structure of space-time itself, the conversion factor between space and time woven into the fabric of reality. We all move through space-time at the speed c. Massive objects like us move mostly through the time direction, which is why we experience duration. Massless particles like photons move entirely through the space direction, which is why they experience no time. Accelerating through space is literally rotating your world line in space-time, trading motion through time for motion through space. Understanding this transforms our view of the universe from a container where things happen in space and time to a single, elegant, four-dimensional geometric structure, space-time. Light speed isn't a barrier. It's the architecture. It's not about light. It's about everything. This is one of the most profound and beautiful discoveries in the history of human thought. It tells us that the universe is far stranger and far more elegant than our everyday intuition could ever suggest.